All right. So we are in week 5. We made it through the midterm. And now we are starting a new topic. Oh my goodness. That pen is so small. That's the one I want. Cool. New topic, which is counting and combinatorics. So we've seen a lot of examples of this already, and I'll point out, I'll make some connections to examples that we've seen in the past. But now what we're going to do is collect them all into general rules and build up, more sophisticated techniques for handling these counting problems. So today, essentially what we're going to do is go over some of the most fundamental rules for counting. And I think at the end we will get into some pigeonhole principle, which is a fun thing as well. So, counting fundamentals. So the first one is the product rule. And the product rule says how you can count things by counting smaller things and then multiplying the answers, taking the product. So if an object can be broken down into 2 independent pieces, and you can count how many options you have for each piece. So let's say there are n1 options for the first piece and n2 options for the second, then for the whole object, there are n1 times n2 options. So now that I have this written down, let me just say it again and be a little more explicit. So if you have something that you can break down into 2 independent pieces, so by independent pieces, I mean you can break it down into a situation where you can choose anything for this piece and anything for this piece, and there's no restrictions between them. So any choice can go with any other choice. Then basically, to find the number of things that you can get for the total object, you just multiply the number of things you can get for each piece. And this corresponds to the fact that so in terms of sets, this is essentially saying that, let's say we have finite sets A and B. The Cartesian product, the cardinality of this, is the cardinality of A times the cardinality of B. Because this is essentially saying, if you have, the elements of this set are taking something from here and taking something from here. So we can break it down into 2 independent pieces, an element of A and an element of B. And this is saying that the number of choices in total is the number of choices for the one part times the number of choices for the other part. Very nice. And well, let's soon get into some examples, but really quickly I want to say more generally, if we have R pieces, so if you can break it down into 2 pieces, you can write it as the product of the ways you can do those pieces. If you can break it down into a bunch of different pieces, let's say R different pieces, with N1 through NR options for each, then the total number of options, again, you just take the product. So you have N1 times N2 times NR options for the whole. And this corresponds to a similar effect for sets where you're just taking the Cartesian product of R different sets rather than just two. Okay, well, let's do some examples. So here is a, classic counting style problem. How many license plates? Oh my geez. Hopefully that's spelled right, but this is not a spelling class. How many license plates can be made with 3 letters? Let's say they're capitalized, so it's 26 options, followed by 3 digits. So how can we count this using the product rule? And the point is just that we can break it down into smaller pieces, namely each letter and each digit. Because we know how many options we have for each of those things, we can combine them to find the options for the total. So we can write this as, 6 pieces. We have 3 slots for letters and 3 slots for digits. So these are our pieces, and we're just going to multiply the number of things we can put for each piece, right? And so how many options do we have for a capital letter? We have 26. So 26 goes in all of those slots. And how many choices do we have for a digit? We have 10 choices because it's 0 through 9. So we put 10 in each of these slots, and then we just multiply them all together. And for this, you might want a calculator. Good thing I wrote it down. It is 17,576,000. So that is a very basic example of the product rule. Before we move on to the next rule, I want to quickly introduce a slight variation. You will often you will be asked to consider things either with repeats or without repeats. So let me give an example of what that means. How many ways without repeating letters or digits? So in this case, we can still break it down into 6 pieces. We just have to be slightly more careful about how we count them. So we have the same setup, 6 pieces, where it's 3 letters, followed by 3 digits. Why can I not draw this line? There we go. 3 digits. And now, the only difference to do it without repeating is that we still have 26 options for the first letter, but then whatever letter we put in the first slot, we can't put in the second one. So for the second one, we only have 25 options. And similarly, whatever letters we put in the first 2 slots cannot go in the third slot. So for the third slot, we only have 24 options. And the digits work the same way. So for the first, we have 10. Then we've used up 1. So for the next one, we have 9. And then we've used up 2. For the next one, we have 8. And again, if you multiply this together, just to put a number on it, it is 11,232,000 on the dot. So that is the product rule.